straightness. Equation of a straight line. Questions. So I'll give a few questions to try to solve it. Find the locus. Find the locus of points.
So we did some problems in the class.
Okay. What problems? This is okay. So
Yes, sir.
this is the question I gave in the last class. Find the locus of points such that the ratio of distance from two fixed points is constant, and that constant k is not equal to 1. Okay, first of all, let us get to the diagram. So we're talking about two fixed points here. Let us say this is the fixed point A, and let us say this is the fixed point B, right? So this is the fixed point A and fixed point B, and these are two fixed points. Now, to begin with, what happens when k equal to 1? When k is equal to 1, what will happen? So how do you solve any locus problem? Do you remember what is the methodology we use to solve any locus problem? We assume that the unknown point is some point P. Okay? Let P be some point. Let P be a point, and let us say it is satisfying the given condition. So let us say P is any point alpha comma beta. It is satisfying the given condition. What is the given condition? In the question it is said PA by PB is equal to K. So this is the condition given in the question. This is okay. Okay. So A and B are two fixed points and P is a variable point. Now we want to find the locus of P such that it is following this condition. Does everyone agree? Is this the condition mentioned in the question? Is this the
So
condition?
you didn't say that the k should not be equals to 1. You said the ratio of the distance is a fixed constant.
Okay, okay. Fine. So then fine. Let us see what happens when K is not 1 and K is 1. Okay. Fixed constant K. Fixed constant K. Okay. First of all, but do you agree that this is a condition? They told that the ratio of distance is K.
Yes.
This is the question I gave in the last class. Now you see to identify the answer, the simplest possibility is when K is equal to 1. Let us say case 1. Case 1 when K is equal to 1. Okay. So when K is equal to 1, what happens?
Pa equals to bb.
So then we have to find the locus of points such that PA is equal to PB. Can someone tell me what is the locus of points such that PA is equal to PB? That means you are at a fixed distance from two fixed points. What is the locus of point P such that PA is equal to PB? A and B are fixed points. Anyone remembers?
Sir, a circle of radius pa.
No, it's not a circle of radius PA. What are all the points satisfying this condition? PA is equal to PB. And PA, A and B are two fixed points. And if P is any variable point. We discussed this in the last class, remember? What is the locus of points which are equidistant from two fixed points. Not remember this. I told it's very, very important. You have to,
So it is the perpendicular bisector of the
yeah,
line segment formed
very
by
good.
joining the fixed point.
Good, good, very good. So the locus of points which are equidistant from these two fixed points is actually the perpendicular bisector of these two lines. So if you find the perpendicular bisectors of this line segment, it will give you the locus of all points which are equidistant from A and B. Very good. Okay. How many of you remember this from the last class? No one remembers? How many of you remember this?
Sir, I did.
Okay. What about Adarsh and Gulshan? Do you recall this from the last class?
Sir, I didn't attend the last class, sir.
Adarsh? So this is very important. The locus of points which are equidistant from two fixed points is the perpendicular bisector of the line segment. So this is case one. When k equal to 1, then the locus, here the locus will be, locus will be the perpendicular bisector, will be the perpendicular bisector of the line segment AB. The locus will be the perpendicular bisector of the line segment AB. ठीक है? Right? So now let us come to case 2. Case 2 would be case 2 if k does not equal to 1. So if k is not equal to 1, then what would the locus be? So this becomes a little more, it is a little geometrically oriented question, but it's a very, very, very good question. Okay? And I'm sure it will be a very good learning experience for all of you. So let us consider 2 points, A and B. We want to find the locus of points such that if you take the distance of any point from this fixed point, and if you divide it with the ratio, sorry, if you divide it with the distance PB, then you should get PA by PB is some constant. Now, before I go there, from your school geometry, all of you are studying in 10th class. I'm sure all of you must be doing geometry till 10th class. Do you know any geometrical theorem which talks about the ratio of these two corresponding sides? Which geometrical theorem talks about ratio of these two sides, PA by PB? Can you recall any geometrical theorem which talks about ratio PA by PB?
Similarity.
See, similarity is not a theorem. Okay, similarity is a tool for comparing two triangles. But I'm talking about a particular theorem where you actually write the ratio of two corresponding sides is equal to some other ratio. It's a very, very famous theorem and it is part of 10th class geometry. 10th class CBSE geometry, so all of you must be doing it because ICSE students must have studied it before. Surprising, no one remembers. There is a theorem which talks about this particular ratio in geometry. Ratio of two sides is equal to some other ratio. See, there are two important theorems in geometry which is studied in 10th class in triangles. The first one is called as Thales theorem. How many of you have heard of Thales theorem or midpoint theorem?
Yes, sir, I had.
So what does Thales theorem state? What does it say? Anyone? What is Thales theorem or midpoint theorem?
The line segment joining two midpoints is parallel to the third side.
Yeah, good. So if you join the midpoint of two sides, it turn out to be parallel to the third side. Okay, good. So this is your Thales theorem. Now, what is the other important theorem you learned in 10th class? I am surprised no one is answering it. There is one more theorem related to triangles which is taught in 10th class and is very important. And in that we use this ratio PA by PB. Oh, so either you guys have not been taught or unfortunately you're not able to recall. I guess you're not able to recall this theorem. It's a theorem called as internal angle bisector theorem. How many of you were taught this at school? Internal angle bisector theorem. Has anyone heard this before? Internal angle bisector theorem. Internal angle bisector theorem? No one.
No, sir, never
No, sir.
heard about it.
Oh, is it? Okay, then welcome to today's class. Today's day you'll be taught. So internal angle bisector theorem states that in a triangle, if you draw the internal angle bisector through a particular vertex, let us say vertex P, and let us say that internal angle bisector intersects the opposite side at a particular point, let us call it C in this particular diagram. Then internal angle bisector theorem states that PA by PB is equal to AC by BC. The ratio of PA and PB will be same as AC is to BC. How many of you have heard this before? None of you heard this?
No, sir.
No, sir.
Oh, that's very surprising. Okay, we'll do one thing. Maybe all of you can try to prove this. All of you try to prove this. Take 2 minutes time and try to prove this. Let us prove this first. And I'm giving you a hint. Begin. Hint is you have a triangle, and from the triangle you are drawing the internal angle bisector. Hint is you just extend this side. Let us call this ABC. So then you draw a line parallel to this through vertex C. Let us call this point B. Okay. So these two are parallel. Now try to do the theorem. See A, B, C, D, and let us call this point E. Now, what is A? What is A? Can someone tell me, according to the question, what is A?
Sir, angle bisector.
Of vertex A. Very good. Okay. Now you have to prove this. You have to prove that AB by AC is equal to BE by EC. Okay. You have to prove that AB by AC is equal to BE by EC. How will you prove this? You can prove this using midpoint theorem or using Thales theorem you can prove. Take 5 minutes and try to prove it. Use Thales theorem. Okay. Because you have parallel lines. Huh? Think about it a little. Try to prove this. Yes.
Hello, sir.
Thank you. Yes. Go ahead. Yes, Arnish.
I will tell how I
Yes.
did.
Hmm.
Um, I did was that BAE angle BAE is equal to EAC because
I'm
angle
calling it alpha,
bisector
okay? Alpha, alpha.
alpha alpha. Therefore, ACD is also alpha because alternate angles
Yeah, very
of
good.
parallel angles, and ADE is also alpha. ADC is also alpha because corresponding angles to BAE.
Yeah, good. ADC is also alpha, no?
Yes,
Angle ADC will be equal to angle BAE. Okay? What was the reason? This will be alternate angle. They are alternate angles, and this is because they are corresponding angles. I think everyone knows what corresponding angle, alternate angle is. When you have two parallel lines, okay? Okay, everyone is clear till here? Is it okay with everyone? These 2 points? Yes?
Yes.
Right. Next, Arnish.
then we can say that as ACD and angle ACD and ADC is equal to alpha, therefore angle ADC is isosceles and AC is equal to AD.
Right, good. Next.
Um, as AE and DC are parallel, therefore by Thales theorem we can say that BE by EC is equal to BA by AD.
Yeah, good, good, very good. This is the important step. So this step is important. From Thales theorem, we can actually tell, since now you have a triangle where A is parallel to DC, you can tell that it divides the opposite sides in the same ratio. That is, we're talking about triangle ADC, sorry, BCD. In BCD, we can tell BA by AD. Whatever ratio this line is dividing this side, BA by AD, in the same ratio, this parallel line will divide the other side also, BE by EC. How many of you know this theorem?
Sir, I knew.
Of course, Vishal and Arnesh. What about all the other students? Others, PS Gulshan.
Yes, yes, sir.
Yes, yes. ठीक है ना? चलिए. So now for the final finishing touch. What is the finishing touch?
Sir, as from before, AC is equal to AD, then therefore we can
Correct.
replace AD with AC. Therefore, the following proof is done.
ठीक है. हो गया. ठीक है. Hence proved. Very, very important. In geometry, this is very important. Okay. I'm surprised you guys don't know because it's taught in 10th class only. And it has many applications later. So this is called as internal angle bisector theorem. Okay. Is it understandable?
Yes, sir.
We'll come back to case 2 later. Let's come back to case 2 later. First of all, you can write down internal angle bisector theorem. Let me make it a little bit more neat. It states that if you have a triangle, it states that if you have a triangle, and if you draw the internal angle bisector of that triangle, and it is meeting the opposite side of D, then this theorem states that this internal angle bisector divides the opposite side in the ratio of the sides containing the angle. What are the sides containing the angle A? The sides containing the angle A are AB and AC. So that is the same ratio in which the internal angle bisector will divide the opposite side, BD by CD. This is internal angle bisector. Okay? ठीक है?
Yes, sir.
That is the theorem and this is the proof. Done. So let us go ahead. Can we move ahead? Did everyone copy this? So proof is like this. What is the proof? Step one is you have to construct. What is the construction? You have to extend this. From A you extend the side, and from C you draw a parallel line. ये दो construct करने से actually 80% of proof खत्म हो गया. Next you can use the properties of transversal and parallel lines. Okay, this AC becomes a transversal to the parallel lines AE and CD. From there you use the properties of alternate angle and corresponding angle. आपको proof खत्म हो जाएगा. ठीक है? So the construction part has a lot of significance. After which the remaining things follow. प्रॉपर्टीज ऑफ ट्रांसफर. ठीक है, चलो आगे चल रहा हूँ. देखिए अभी इसको कैसे यूज करेंगे इसमें. हाउ इन द वर्ल्ड इज दिस रिलेटेड टू दिस क्वेश्चन. इट्स वेरी मच रिलेटेड. व्हाई? बिकॉज दिस इज अ थ्योरम व्हिच इज टॉकिंग अबाउट रेशियो ऑफ टू साइड्स. ठीक है. नाउ व्हाट इज आवर क्वेश्चन? व्हाट इज द क्वेश्चन ऑफ previous class question is asking, suppose you have two fixed points A and B. Then what is the locus of the third point P such that PA by PP is some constant and that constant is not equal to 1. Okay. If that constant is equal to 1, the locus will be perpendicular bisector. वो तो हो गया, वो last class में discuss कर दिया. But what if that constant is not equal to 1? What is going to happen? So let us say this is A and let us say this is B. And if PA, we want to find PA by PB. PA by PB is equal to K by 1. Okay, so now let us draw the internal angle bisector of this side P and the external angle bisector. Acha, what do you mean by external angle bisector? Oh, do you guys know external angle bisector? Logically सोचे क्या होगा? You can try to guess.
Sir, the external angles bisector, the like B
Yeah,
P.
yeah. Good. See, actually क्या ये भी एक अलग theorem है, but you see, generally it just follows. Everyone understands it automatically. So let us say that the internal angle bisector is cutting side AB at D, and the external angle bisector is cutting side AB extended AB. It is cutting at the point D dash. Okay. Then this is the external angle bisector. मतलब ये दोनों sides equal. यहाँ ये दो angle equal है और the external angle is also being bisected. Then actually there is a theorem. There is one more theorem which is exactly same to what we just studied. That is called as external angle bisector theorem. What does the theorem state? That theorem states that if D dash is the external point where the external angle bisector is cutting the opposite side AB. See, AB extend करने के बाद D dash point पर है, ठीक है? So then this external angle bisector theorem, external angle bisector theorem. I want you guys to guess. Just make an intelligent guess what the theorem might be stating. Make an intelligent guess. Proof कुछ जरूरत नहीं. Just make an intelligent guess. Try to guess.
Sir, the bisector will divide the opposite sides in the same ratio.
Bisector will. थोड़ा बोलिए mathematically. Just tell some equation. कुछ equation बोल सकते हैं? बाबू, विशाल, कुछ mathematical equation. Tell me some mathematical equation.
Sir, AD dash by AB is equal to PA by PB.
AD dash by AB is equal to PA by PB. I think you have to change this. Try to think again. Instead of AB, what can you write here? See, AD dash is distance from one vertex to this point divided by, I think it should be B by BD dash. AD dash divided by BD dash. That seems more logical, na? That looks more
Yes, sir.
symmetric.
Yes. Yes.
AD dash divided by BD dash is equal to PA by PB. This is external angle bisected. Okay. And in this question, this is also given as K. One second. I'll tell the one way of easily remembering this. A very easy way of remembering this theorem is, it is same as internal angle bisected theorem. बस एक ही फर्क है. Instead of D dash, if you put D, it will become internal angle bisected. If you put D dash, it becomes external angle bisected. ठीक है? Equal to K by. Right. Now see what I'm going to explain. It is something that you will require little good understanding. थोड़ा अच्छा से सुनना पड़ेगा आपको, ना? Focus on what I'm going to tell. Everyone remembers section formula? Section formula, do you remember section formula? Coordinate geometry?
Yes, sir.
Okay.
Yes, sir.
So, who can tell me how to find point D and point D dash if I tell that A and B are given and the ratio K is given? Can someone explain how we can find D and D dash? If I give you any 2 points in space, fixed points, okay? I give you 2 fixed points A and B, and I tell that find the 2 points dividing it in the ratio K is to 1. What will you do? Find 2 points which will divide it in the ratio K is to 1. You have 2 fixed points A and B, right? And the question says find 2 points which is dividing it in the ratio, let us say 3 is to 1. How will you do it? Forget how to do it. What does it mean? Physically, what do I mean by 2 points? 2 point कैसे रहेगा? How will I have 2 points dividing it in the ratio 2 is to 1, 3 is to 1, whatever? See, 1 point is inside, that is very easy to understand. Let us say AD is to BD is in the ratio 3 is to 1. We can all understand that. That means if the total distance is 12, if the total distance is 12, then AD would be, how much would AD be, how much would BD be? For it to be in 3 to 1 ratio.
So AD 4, DB.
Ulta.
4, 8.
AD will be.
Not.
Wow. छोटू क्वेश्चन में सब बोल्ड हो गया.
So 3 and
Con 3, con
9. 3 and 9.
Con 3, con 9.
AD is 9, AD is 9, and DB is 3.
Good. Okay. So if I tell the distance between AB is 12 and it is being divided in the ratio 3 is to 1, then it is some point in between which is at a distance of 9 from A and at a distance of 3 from B. यहाँ तक सबको clear है? You understand what point D means? Okay. So if I tell find the point D which is in the ratio 3 is to 1 from AB, which divides AB in the ratio AB by BD. If I tell it is in the ratio 3 is to 1, internally you'll have 1 point. Now, can I say that I'll have 1 point externally also? वैसे बोल सकते हैं कि externally भी एक point रहेगा in the ratio 3 is to 1. Are you able to conceive the idea? Or are you able to visualize it? बाहर भी एक point रहेगा ना, such that AD will be 3 and BD will be 1, 3 is to 1 ratio में. हाँ, हो सकते हैं ना? Like let us say from maybe from here to here, D dash, it is possible na, it can be some 12 units and this can be only 4 units. BD dash is 4 units and AD dash is 12 units. ऐसे हो सकते हैं ना? हाँ?
Yes, sir.
So then, can I say you'll always have 2 points which will divide 2 fixed points in a particular ratio? What are those 2 fixed points? Those 2 fixed points you'll get by using the section formula. Once you put k is to 1 and other time you put minus k is to 1. Remember, if PA is by PB is equal to, if I put a negative sign, what will I get? I'll get the point dividing these 2 fixed points externally. I discussed this. Do you guys remember? It will give the external point of division. Okay. Did we discuss this in coordinate geometry?
Yes, sir.
So, one second. Just a second. Yes. So for a fixed number k, you'll have 2 points which divide two fixed points in that ratio. One will be the internal point of division and other will be external point of division. Is everyone clear with this? Okay.
Yes, sir. Clear.
Is everyone clear? So then we're continuing the proof now. So for every fixed points, if you have any two fixed points A and B, there will be 2 points which will divide it in the ratio k is to 1. One will be an internal point and the other one will be an external point. Okay? Now I'm going to tell something very important. What will be the angle between these two angle bisectors? What is the angle between the internal angle bisector and the external angle bisector? This will be a by 2, a by 2, and this will be 180 minus a divided by 2. What is 180 minus a divided by 2? 90 minus a by 2 and 90 minus a by 2. Okay. So what is the angle between the internal angle bisector and external angle bisector? ये होगा. Tell me what is the angle between internal angle bisector theorem and external angle bisector? इंटरनल एंगल बाइसेक्टर और एक्सटर्नल एंगल बाइसेक्टर के बीच में एंगल क्या होगा? ये पूरा कितना होगा?
So 180.
नहीं बॉस, फ्रॉम हियर टू हियर बिटवीन टू लाइंस एंगल 180 कैसे हो सकता है? Oh, you guys didn't understand. ठीक है, I'll make a bigger diagram. again, I'm telling for any triangle. First of all, ABC is a triangle. यहाँ तक clear है सब, ठीक है? Now I'm extending a side AB. I'm extending a little. Why am I extending? Let us say I extended till A. E. Why am I extending? I'm extending so as to make the external angle bisector. External angle bisector का मतलब क्या? See, if this angle is A, what is the external angle? If internal angle is A, external angle will be
180
Sir,
minus
180 minus A.
okay. 180 minus A. Very good. Now next part. What is the internal angle bisector theorem? It is internal angle bisector. It is a line which divides this angle into two equal parts. So what will those two equal parts be? A by 2,
A
A by
by
2.
2.
Now what do you mean by external bisector? External bisector is the line dividing this external angle into two equal parts. So if I divide this into two equal parts, what will those two parts be?
180 minus A by 2.
Correct. Which is
90 minus A by 2.
99. ठीक है, that is what I was trying to do. ये पूरा 180 minus A हो गया. So each of the small angles will be 90 minus A by 2. ये भी 90 minus A by 2. ठीक है? Now this is a very very important point what I am telling. What is the important point? What is the angle between the internal angle bisector and external angle bisector? This is very important. ये पूरा एंगल कितना होगा between these two bisectors? What is the angle?
90.
90. ठीक है? It is not just I am asking it as a question. It is something all of you have to remember. The angle between the internal angle bisector and the external angle bisector will always be 90 degrees. ठीक है? For any two lines L1 and L2, the angle between the two bisectors, that is, this is bisector 1 and bisector 2, दोनों के बीच में हमेशा एंगल कितना होगा? 90. Is that clear?
Yes, sir.
ठीक है? So I think we are learning a lot. This is one question, but within one question we learned so many things, right? Quite exciting, no? Right? We are still not done with
Yes,
the
sir.
question. Okay, we're still not done with the question. Now, the last installment of this exciting question. यहाँ तक copy कर दिया? Did everyone copy stuff कर दिया?
Yes, sir.
I think we'll go through the entire problem one more time. So the last step, what is the last step? The last step of this problem is we have two fixed points A and B. Okay? We have two fixed points A and B. If you have two fixed points A and B and you have a fixed ratio, in which these 2 points are being divided, then we'll obtain two fixed points D and D dash. If you know some fixed ratio, if you want to find what points divide this in the ratio, in a fixed ratio, let us say K is to 1, then you will get two fixed points D and D dash. ठीक है? यहाँ तक clear है? We did discuss all this before that. Now what are those two fixed points? Those fixed points will be for any particular point P. What will those 2 points be? Those 2 points will be the end points of the internal angle bisector and the end point of the external angle bisector respectively. For any random point, arbitrary point P, D and D dash will be the end where internal angle bisector theorem is meeting opposite side, and the point where external angle bisector theorem is external angle bisector is meeting the opposite side. किसी को कुछ doubt है क्या? See, because when I explain, sometimes I might be unclear. Did anyone get confused anywhere till now?
No, sir.
I'm sure all of you must be confused, but I'll go through it once more. Okay. So because it's very elaborate. Now see, it's very beautiful. The conclusion we're going to come to is very beautiful. See, now I'm just where we want to find the locus of point P. Remember, that is the question. What is the locus of point P such that PA by PB is equal to constant? ये था question, है ना? Now we are just changing the language of the question a little. Instead of saying PA by PB is equal to K, we can tell that there are two fixed points D and D dash, which is subtending 90 degrees at a variable point P. We want to find the locus of the point P where two fixed points D and D dash is subtending 90 degrees. So what will the answer be? Thus P is a point where two two fixed points. Thus P is a point where two fixed points D and D dash subtend 90 degrees. Thus P is a point where two fixed points D and D dash subtend 90 degrees. If you remember, what is the locus of a point where two fixed points subtend 90 degrees? This was the first question in the last class. If I tell that two fixed points are subtending 90 degrees at a variable point P, what is the locus of the point P? किसी को याद है?
A circle with A and B sense of diameter.
Very good. It is nothing but the circle with A and B as the ends of diameter. ठीक है? So thus P is a point where two fixed points D and D dash subtend a angle of 90 degrees. In other words, the locus of P is the locus of P. In other words, the locus of P is a circle. Can someone complete the sentence for me? What is the locus of P? The locus of P is a circle having, please complete it. The locus of P is a circle having
D and D dash a sense of diameter.
okay, having D and D dash as ends of diameter. But see, Vishal, D and D dash क्वेश्चन में कुछ दिया क्या? D and D dash आपको क्वेश्चन में कुछ D and D dash दिया क्या? Is there any mention of D and D dash in question?
No, sir.
No. Question is talking about two fixed points. So if question is talking about two fixed points, can you answer in terms of D and D dash? नहीं हो सकते ना. Answer you cannot give answer in terms of something you define. ना you define D and D dash. So you have to mention now what is the meaning of D and D dash. समझ गए ना?
Yes, sir.
Very important. This is something very important in maths. आगे आप लोग sometimes you are going to solve some question by introducing some variable t. You are going to say let this is equal to some y or let this be equal to x. And after you simplify the entire answer, you'll get some x cube minus 3. मान लीजिए. So will you leave the answer like this? No, this will always be wrong. What you should do, if you introduce the variable x, then you should go back to the definition of x and write it in the form of the question. Question में जो variables है उस form में लिखना होगा. You cannot write answer in terms of variables which you have introduced. Okay, this is a small but important point. So since we are introducing D and D dash ourselves, we have to define what is D and D dash. So what is D and D dash? Where D and D dash, where D and D dash are the where D and D dash are the ends, where D and D dash are the ends of the ends of the internal and external angle bisectors, where D and D dash are the ends of the internal and external angle bisectors on the on the opposite side through the vertex P, through the vertex through the vertex. What I'll do, so let's go through the whole theorem one more time, right? So theorem, the entire theorem goes like this. Let's start from a fresh page. The entire theorem goes like this. It is telling that find the locus of any point P such that it is having the ratio from two fixed points. The ratio from two fixed points is a fixed constant. You have to find the locus of points such that the ratio of distances from two fixed points is a fixed ratio. Now you have to find that point P such that PA by PB is a fixed ratio K is to 1. Okay. So find the locus of all points such that PA by PB is a fixed constant. So what is the flow? What is the thought process? The thought process would be as follows. The thought process would be PA by PB has to be a fixed constant K. So what would that fixed constant be? We have learned in coordinate geometry section formula that if we have two fixed points A and B, if A and B are two fixed points, and if I tell find the point which is dividing these two coordinates in the ratio K is to 1, then how many points can we find? Yes, how many points can we find? We can find 2 points. What are those 2 points? The 2 points will be the points dividing it in the ratio K is to 1 internally and externally. Okay? So if you're given 2 points A and B, if you're given the coordinates and if you're given the ratio in which it is being divided, K is to 1, then using the section formula, you can find 2 points in which it is being divided. One will be the internal point and the other will be the external point of division. One time you take plus sign, and other time if you take minus sign, you'll get the 2 points D and D dash. Okay. Now the next step is, since the question is telling that PA by P is equal to K, from internal angle bisector theorem. In geometry, we saw that internal angle bisector theorem states that PA by PB is equal to AD by BD. And external angle bisector theorem tells that PA by PB is equal to AD dash by BD dash. And all of this is given in the question as K by 1. Okay. So therefore, using this data, we are able to find the points D and D dash. And they will respectively be the opposite ends of the internal angle bisector, and it will be the ends of the external angle bisector. Okay. And then we use the next theorem. What was the next theorem? The next theorem was the angle between internal angle bisector and external angle bisector will always be 90 degrees. The angle between internal angle and bisector and external angle bisector is always 90 degrees. And now what is the final finishing touch? The finishing touch is we have two fixed points. We have two fixed points D and D dash, which is subtending a fixed angle 90 degrees at a particular point, and we have to find the locus of that point. So what is the locus of point where two fixed points is subtending 90 degrees? So the locus of points where two fixed points subtend 90 degrees will be a circle having those 2 points as the ends of diameter. So therefore the locus of any variable point P Therefore, the locus of P is the circle having D and D dash as the ends of diameter, where D and D dash are the ends of the internal angle and external angle bisectors on the opposite side to the variable point P. This is the entire theorem. Okay.
Sir, then what will be the center of the circle?
Very good. Hey, Vishal is asking a simple logical question. What will be the center of the circle? Anyone can answer. I see some ninth class students have also joined. It's a very simple question. If I tell D and D
So
dash
can
are,
I say,
yeah, if D and D dash are the ends of diameter, what will be the center?
so D plus D dash by 2
Vectorially
means
speaking,
the
midpoint of D and
we
D
have
dash.
to find the midpoint of D and D dash.
Yeah, very good. So if you know the coordinates of D and D dash, can you find the midpoint, Vishal?
Yes, sir.
So we can find the center of the circle as a midpoint of D and D dash. ठीक है? Okay.
Yes, sir.